check our answers, okay? The hell? Okay. Now, in this question, it says that 64 adults were asked to indicate the weekly number of hours. So, you can just write down, it's exercise 3C, question 5, yeah? Okay. So, they were asked to indicate the weekly number of hours they spent on watching television. The cumulative frequency curve is shown over here, and we need to first use the graph to estimate the median interquartile range, as well as the number of adults who spend more than 25 hours per week watching television. Okay, so typically when you have a cumulative frequency curve, it is always a less than, otherwise less than or equals to. Okay, from the phrasing that we see over here, asking more than, it will tell us that this cumulative frequency curve will have to be a less than or equals to cumulative frequency curve. Okay, so looking at part IA first. Alright, just do a very quick check of your own answers. The median should actually be 15, and then the interquartile range should be taking 19 minus 12, such that we have 7. Okay, I hope you are able to get these answers. Okay. Then in part C, we want to find the number of adults that spend more than 25 hours per week watching television. Okay, so we can go and find out at 25 hours, which is over here. Okay, what we will read off from the graph will be the value 58. Okay, but this 58 refers to less than or equals to 25 hours. So the number of adults in this particular question will be to take into consideration the end point of the curve over here, find out what is the maximum number of adults, okay, which should be 64, because in the given question it also says 64 already. Okay, so I hope that you are not taking 70 minus 58. It should be 64 minus 58. Okay, and that should give us a value of 6. Okay, so part C answer should be 6. And then, following the question, it gave you a box and whisker plot showing the number of hours that a group of 64 teenagers spent watching television. Okay, so earlier on it's 64 adults, now it's teenagers. Okay, we want to find the median interquartile range. Okay, for a box and whisker plot, it's much easier for us to read. Median will just be the one right in the center. Okay, and then the interquartile range will be to take the difference over here. Okay, so median should be 34. Interquartile range will be 24. Okay. Right? And then in part 3, it states that the teenagers spent more time watching television in general. Okay? Do you agree? Give a reason to support your answer. I just want someone to give me an answer. Let me just pick for my ice cream sticks. It says Lavelle. Lavelle, do you have an answer for part 3? Any attempt? I'm looking in the right direction, right? Lavelle is there, right? Any attempt? And can you try? In general, okay, so what should we be looking at? Median or interquartile range? Can you answer me that? Interquartile range. The question says teenagers spend more time watching television in general. We should be looking at median. Why? Because median is a measure of average. Okay, so in general, we'll kill you to make use of median. Okay, so we compare the two medians values over here. This one is 15, down here is 34. Okay, we find that the one for teenagers, which is this data here, has a larger value than the ones for adults. Okay, so the value over here tells us about the number of hours. Okay, so actually really speaking, there should be all the units up. Okay, so this means that in general, looking at the median itself, the teenagers indeed spend more time watching television in general. Okay, so you agree? Yes, but then you need to give a reason, and the reason we give is that the median value here is greater than the median value for adults. Our conclusion for part 3. Okay, next we look at part 4. Yeah, it says that make a comment comparing the spread of the time spent watching television between these two groups of people. So because we're looking at spread, we should be comparing our interquartile range. Okay, we find that the interquartile range for adults is smaller in number than that of the teenagers. Okay, with this being a smaller number, it means that the data values of the middle 50%, okay, because interquartile range is to take the upper quartile minus lower quartile. We're taking the middle 50%, okay, we find that it is more consistent, okay, towards around the median itself, okay, more consistent around the median. Alright, so in order to explain that or comment about it, here we say that the number of hours spent on watching TV actually my conclusion by observing the interquartile range. Okay, and then later on I need to explain by pointing out about the differences in the interquartile range, or rather draw the comparison. Okay, it would be very lengthy, right, to actually go about writing the same thing again in a very long manner. So I learned, okay, a very simple English word that makes things easier for us. Okay, and that is the word former and latter. Okay, you know how to use former and latter, right? F-O-R-M-E-R. You know these words, right? Okay, so former is the first one, latter is the later one. So we draw reference to what we have written over here. The former one will be talking about adults, the latter will actually be the teenagers. Okay, so we just say because the former has a smaller interquartile range than the latter. Okay, I find these two words very easy to use and helps us to write lesser. Okay, any questions? It just struck me one thing, okay, that I forgot to mention the other day. When it came to percentiles, okay, when it came to percentiles, right, we know that percentile means to take the data, we divide into 100 portions, 100 parts, and then we look for maybe the 80th percentile, 70th percentile, accordingly to the data. Okay, I think it's also important for us to realize that the first quartile is the same as the 25th percentile, the median is the same as the 50th percentile, and the upper quartile is the same as the 75th percentile. Okay, so because your median is at the 50th mark, okay, and then after that your upper quartile is at the 75th upper quarter, 3 quarters. Okay, 3 quarters will be 75 over 100. So you need to be able to recognize this as well. Okay. Question 8 in your exercise 3C. Okay, something that deviates from our usual question. It says over here that the following diagram shows the box and whisker plot for the alcohol content in the blood of drivers who were given breathalyzer test. Okay, state the lower quartile, median as well as the upper quartile. I think it is straightforward at this juncture. Perhaps not so much for those that missed the lesson yesterday. But the lower quartile is to be read from this end of the box. Okay, we find that it is actually 0.05. Right? The median, which is also Q2, will be read from in the middle of the box. We find that it is 0.07. And then lastly, the upper quartile, in this case, would be about 0.085, if I'm not wrong. 0.086. So our data is actually about the blood alcohol content, and that is measured by this unit, gram per dl, that's deciliter of blood. Okay. I want us to pay attention more on the part 2 of the question. Okay, it says make one comparison between the spread of the alcohol content between the highest 25% of the drivers and then also the lowest 25% of the drivers. So the question specifically asks you to talk about the spread, okay? And you cannot always intuitively think that spread means compare IQR, okay, or your interquartile range. Because in this case, interquartile range, there's only one value. There is no other value for you to talk about, okay? In fact, the question is asking for the spread between the highest 25% and the highest 25% refers to this portion over here. Okay, and then the lowest 25% will actually be over here. Okay, so the question is asking us to compare the spread. Okay, spread, that means the so-called wideness of the data values. So visually from a box and whisker plot, I can see that this line is longer than this line. So this means that for the highest 25%, the spread is wider as compared to the lowest 25%. Okay, so you just have to describe that out in words, which is exactly what I just said earlier on. Okay, so we say the spread of the alcohol content for the highest 25% of the drivers is greater, or you can say wider, than that of the lowest 25%. Questions? Of your box and whisker plot, look at question 10. Okay, no need for any explanation for question 10. Okay, we just need to be able to see from the box and whisker plot and answer the question. Okay, so in question 10 it says that there are 3 different box and whisker plots that shows the masses of 3 types of apples. Okay, which type of apple has a greatest median mass? Okay, so just from the box and whisker plot itself, which one do you think has the greatest median mass? Chloe, type A, right? Okay, so we can clearly see that type A is the one with the greatest median mass just by comparing the middle line of the boxes. This one is higher. Okay, so for I part A, type A. Then in part B, okay, we want the least median mass, and naturally we see that it will be type C. Okay, then in part 2, we want to answer this question where it says which type of apple has masses which have a greater spread. Okay, so which one do you think has a greater spread in this case? What do you think your answer would be? Amelia? Sorry? A. Do you say A? B. Oh, so I cannot hear you. I mean, so you say so fast that you cannot hear you. Okay, so B, yes. Okay, so B has the greatest spread. Why? Because we see that just by looking at the range itself, it is wider as compared to A and C. Okay, so right. It says which type of apple has masses which are more evenly distributed compared to the other two types. Okay, and they're asking you to explain. Right? So in this particular question, what will you actually choose? And Jovia is not here. Okay, using yesterday already, right? Shishan, what do you think? Sorry. Which one actually is more evenly distributed? B is more evenly distributed. So why? How will you explain it? The median of it is type B is about 250 grams. So therefore it is more evenly distributed. The range, what about it? The data range is smaller. No, so can you be more coherent in your answers? Can you look at the symmetry of the diagram itself? Okay, because the question is asking for something that is more evenly distributed. Okay, so because we are looking for evenness, okay, we look at the symmetry of the diagram. Okay, so if let's say I look at type A instead of looking at type B, type B is the correct answer, no doubt. Okay. If you look at type A itself, why is it that you wouldn't choose type A as the answer, Shishan? Visually from type A itself, what tells you? One got what? A lot more what? Apples. The space, is it? Okay, so we look at just the space itself, the length, okay, the distribution or in fact the spread. Okay, this one has a wider space than this space itself. Okay, so actually it's not so much evenly distributed because we know that the median is supposed to be the halfway point. Okay, halfway point of all the apples there are. Okay, but this spread is wider than this one. That's why this is not considered evenly distributed just by the middle 50% alone. But then if I were to look at the lines itself, right, this is longer than this one. Okay, so I will also see that this is not evenly distributed at the bottom 20% and the higher 25%, bottom 25% and the higher 25%. Okay, likewise looking at type C, it is not even, they are not equal, okay, in terms of the spacing itself. So we conclude that type B is the answer because just by looking at the spaces, okay, the symmetry of the diagram, we see that it is more evenly distributed as compared to type A and C. Okay, so we explain by saying in the box that we still plot, okay, we just say that it's symmetrical among the median. Okay. We just look at the visual appearance will do. No need to go and measure, so don't need to go and take a ruler and then really measure this out. Because if I really want to be precise, I'm quite sure this is longer than this one. Okay, so we're just going with an estimate, okay, in order to decide on this. Alright? Questions? Okay, I want all of us to prepare our calculators now, okay, so that we learn our standard deviation. But just slightly before that, I want to talk about what is standard deviation. Okay? Let me just turn it off first. Okay, before I forget, so homework for exercise 3C. Question 479. Page 111 to 111. Okay. So in standard deviation, or the reason why we look at standard deviation, which is a measure of spread itself, okay, is because standard deviation is defined surrounding the mean. Yes, you see. Due when? Due Friday. Okay. Right. So mean itself is definitely a much better measure of average. So a quick recap again. Measure of average. We have our mean, median, and mode. And yesterday, I briefly mentioned that, okay, we choose median as a measure of average when our mean itself, okay, has extreme values. Okay, again, the example of maybe one person, okay, getting 0 marks versus the rest of the class getting more than 70 marks. Okay, then that one person who got 0 will definitely pull the mean downwards. Okay, otherwise, alternatively, we can also see a case whereby everybody get 50 marks, one person get 100 marks. Okay, then definitely the mean will also be pulled upwards slightly. Okay, so mean is very sensitive to extreme values. Alright, that's why we choose median, okay, to describe the data in the average manner. Okay, but with the measure of average, we also have corresponding measures of spread. Okay, whereby mean we compare it to standard deviation, or we rather place together as a pair. Median we compare it, we place together as a pair of interquartile range. Okay, but mode doesn't tie in with your range. They're just rather independent things to talk about. Okay, independent concepts. Right? So in the cumulative frequency curve, we are unable to actually find out what is the mean or what is the standard deviation. Because in the cumulative frequency curve, all your data points are actually estimated. Okay, we don't know the precise data value itself. Okay, we can only find mean when we have the precise data value. Otherwise, we may do some estimation, which we'll talk more about it again later on. Okay, so in standard deviation, being a measure of spread, it is a measure around the mean. So again, we think about it as though mean is being in the center. Standard deviation, instead of it being a diameter, we're looking at it as though it is a radius. Okay? Okay, so actually when you have a standard deviation value, okay, it will actually be a plus minus. So for instance, since I have my laptop over here, okay, whenever we want to analyze your results, what do we do? Hang on, give me a while. Okay. So being math teachers, we definitely compare your results in a very statistical manner. So we don't look at mean, we do look at your mean, standard deviation and all that. Okay, so for example, I never say whose results this belongs to. Maybe let me hide things a little bit. Okay. Sorry, I realize I cannot hide. It's your results. Okay. So your WA1 results. Okay. So for example, standard deviation being 13.65. Okay, and then the MSG is your mean, so 1.95. So that's great now. Okay, so standard deviation is plus minus value from your mean itself. Okay. Alright, so we look at everybody's data value, and then after that we calculate that the standard deviation is this. Okay, so that means we have people that could be very far away, right, from the mean value itself. Okay, actually looking at this number, I find it a bit strange. 13.65, is it even possible? Maybe there's a problem in the formula, okay? But never mind, okay? Just taking this as an example lah, okay? Because strictly speaking, this number doesn't quite make sense, I think. Okay? Alright? So that's what we see and understand about standard deviation. Okay? There is a formula for standard deviation which you will find in your formula list. But with our calculators, very rarely we need to use it. So long as you know how to press your calculator, okay, you're fine. Right? So in your formula list, the standard deviation formula that's given to you will be written in this manner. So if you have ever scrutinized your formula list, you will find that standard deviation is given to you like that. And in fact, before the standard deviation, they also gave the mean formula as is. Let me just switch on the lights now. Okay, I want to break it down for you to help you understand what all these notations actually mean. Yeah? Jasper, could you please wake up? Alright, so in this case, okay, this symbol over here, okay, what it means is the sum of. Right? F actually refers to the frequency. Okay, frequency of what? Frequency of the data value happening. Okay, so the number of times, maybe how many people actually got A1 in this class. So that number of people refers to the frequency. Okay, X is actually the data value. Okay. Don't worry, I will show you one time of how we use this formula. Okay, but I will only probably show you 1 or 2 times. After that, we learn how to use calculator. Okay. Because calculator should be the way to go, right? Don't need to go and like really waste your time with this. Okay, so mean is actually this one over here. First, we understand what mean is. Okay, mean we know that it is always taking the data value, add together, divide by total everyone, right? Okay, so for example. Okay, maybe we are looking at the weight of people in this class. Maybe let me change the marker. Okay. I'm not going to ask people's weight, don't worry. Okay. So, for example, we got 40, 40, 48, 48, 48, 52, 52. Okay, something like that. Right? Just very light weights. Okay. So we see that 40 has a frequency of 2, 48 has a frequency of 3, and then 52 has a frequency of 2. Okay? We definitely know that the mean value, okay, if I want to calculate it conventionally, I will usually just take 40 plus 40. 40 plus 40 plus 48 and all the way until 52, right? Divide by, in this case, 2 plus 3 plus 2, that will actually be 7. Right? Okay, so that is how we calculate our mean conventionally. But I also know that I can do it in other ways where I just take 2 times 40 plus 3 times 48 plus 2 times 52. Okay, and then I still divide by 7. Right? And this is exactly my application of the mean formula, whereby I'm summing up, okay, the multiplication of the frequency, which is these two over here, and then the data value 40. So I'm taking the frequency times the data value and then add them up. Okay, that is what this formula actually means. Okay, then divide by the total frequency. This represents sum of frequency, and that is actually 7 in this case, because I take 2 plus 3 plus 2. Okay. Right, so this is frequency, this is data value. Okay, and then in total, this is what we see as sum of frequency times x. And over here is sum of frequency. Okay? I'm not trying to make you feel very troubled over this formula. Okay? I just want to explain what is stated in your formula list. Okay? So that at least you see in your formula list, you don't get stunned and you don't get shocked. Okay? But nothing wrong with going with our convention, what we already know, where we take the data values, add them up, okay, and then divide accordingly. Okay? So, with that understanding of mean, okay, the same thing actually applies for standard deviation. Right? So, it is always taking the frequency times the data value square divide by the sum of the frequency over here. Okay? So, in this particular case, if I want to look for the SD, okay, it will actually be the square root of frequency times x squared. So, frequency is 2, x squared is 40 squared, plus 3, 48 squared, plus 2, 52 squared, over total frequency minus away mean squared. Okay, I'm not going to calculate this out, but this is what it should look like if I'm trying to apply this formula to this data. Okay, this thing is your mean. Okay. Formula is being applied. Alright? If you get it, you get it. If you don't need to worry too much about it. Okay? Now I want us to just now learn how to press our calculator. Okay? Okay. I want us to turn to our textbook, page 118, looking at practice now 7. Hang on, let me set up my visualizer. Demonstrate to you once. Next time you ask me again, please go and watch this video yourself. Alright? Okay. Now, this question here. Okay, practice now 7, part I. It shows you that the table below shows the number of grammatical errors made by Yihao in 8 English essays submitted this semester. Okay, find the standard deviation of the number of errors made. So first of all, you must be able to recognize from this table what is the data value and what is the frequency. Okay, so I cannot freeze this on the screen. Okay, the question is talking about the number of grammatical errors. So the data value, your x itself, should be talking about the number of errors. Okay? So this is your data value. Okay? Because in essay number 1, there are 6 errors. In essay number 2, there are 9 errors. Okay, so the data values are actually 6, 9, 15, 26 and so on to 3. Okay, and the frequency of each data value in this case, nothing is repeating. So actually the frequency is 1 each. Okay, in this case the frequency is 1 each. Right? Being able to recognize this is important for your calculator calculation. I just want to do a quick check. How many of you use a Casio? Is it a majority? Okay. If it's majority, then use Casio 1 first. Okay. Right. The sharp one, more or less, the calculator pressing is around the same one. Okay. Sorry, let me just reset my calculator. Yeah. Okay. I zoom in. Okay. Now, in your calculator, the first thing to be observed is that typically you should be on the math mode. Okay? So I hope that you're in that math mode. If you're in the sharp calculator, it's a normal mode. Okay, it's very obvious when it's a sharp one. Okay? So Casio 1 is a very small indication over here. What we need to first do is to change our mode to the stat mode. Okay, so press the mode button and change to stat. Okay, likewise in the sharp calculator, actually I can put side by side, right? Okay, sharp calculator, again press the mode, change it to stat. Okay, alright, then after that, choose the one variance. Okay, VAR stands for variance. Choose number 1. Right? Okay. What you see over here may not be the same for everyone. Okay, I'll tell you more about it in a moment. Whereas for the sharp calculator, you choose 0 SD. Okay. So your screen may not look exactly like mine. Okay. But it should look like there's a table. Do we all get it? Got a table, huh? Okay. So you see that my case over here, I got some numbers already. That's because I was using it previously already. Okay. For exam standard, I don't know why, don't ask me. Okay. But somehow they always ask for sharp calculators to be reset at the start of exam. Okay, for O levels. Whereas Casio, I don't know why they never ask to reset lah. But sharp, they always ask to reset. But we should always have the practice to know how to clear our calculator. Because maybe before the exam, you already got some data inside. Okay, then it will be troublesome to actually go and delete one by one. Okay, so learn how to clear your calculator. You can just go to on button. Alright, there should be a clear CLR over here. For the Casio one, it's actually at button number 9. So you press shift and number 9. Okay, then they'll ask to clear everything. Clear which one? We just clear all lah. Okay. But once you clear all, right, it changes back to math mode. Okay, so just go back to the same steps again. And for me now, once I cleared it, no more frequency column. Okay. Then for the sharp one, likewise, in order to clear, okay, you can press this alpha button on the top. There's memory clear. So second function alpha, okay, can just reset 0. Okay, then so you will be actually expected, no? Okay, for a sharp user, when the invigilator comes around, you will be asked to actually kind of show, okay, this initialized screen. Yeah. Okay, when the invigilator comes around now. I really don't know what kind of invigilator you're getting. Some they really want to see you reset your calculator. Okay, so knowing how to reset your calculator is an important one. Okay, of course there's an easy way out lah. Some people I've seen, okay, go and press the button at the back, but the Casio one don't have button at the back, right? Oh, yeah, got one button at the back here to press the reset one, right? Oh my goodness, what kind of life have you all been leading? I don't know this. Okay, I think you press this, use a pen or pencil, poke it, and then can reset already. Surprise! I thought that was like common knowledge. Okay, I'm glad I did something new that you all don't know. Okay. And right, yours don't have. It's just this one. You cannot open. Oh, nothing happens. Sorry. Oh, okay. So Casio 1 cannot use that. I'm sorry. Sharp 1, Yeah, but it doesn't go to the table. Okay. Oh, wait. Wait, let me try. I think I can see. 1, I try it. How many of you uses this one? The old sharp one. You use? Okay. That one Casio, right? Okay. I think that one should still be the same. Oh, you use Canon. Canon, sorry, I don't know how to use already. Go back to calculator, okay? Yeah. Okay. This one, let me figure out. Okay. I forgot how to use it. Okay. So, okay. Now no more frequency over here, right? Okay. We need to switch on the frequency. So you need to know how to switch on your frequency, yeah? Okay. Sorry, I also forget a little bit sometimes. Let me figure it out again. Okay, I found it. Okay. So when you do into your stat, right? Okay, Casio 1, right? In order to have that frequency column, which is important, okay, you can go back to on. You press Shift Set Up. Okay, Shift Set Up. Press the down button. Go to Full Stat. Okay, then you can switch on your frequency, such that you go back to that same steps. You will now have the frequency column being shown. Okay, it's really up to you what you prefer. If you prefer the sharp calculator format, and I know most of the students would like to bring 2 calculators into exam, then you buy one Casio, one sharp, okay? Yeah, so up to you lah, okay? I'm not here to sell calculators or promote calculators, okay? But if this video goes up and then people want to sponsor me calculators, I guess we don't mind. Alright? Are we able to arrive at this? Okay? The sharp one, sorry, the old model, they are more complicated. Okay? Alright? Can get this table ready? Now we go back to the question, yeah? Okay? Shall we go back to the question? Guys, can I get your attention? Okay? So, just now we said that the number of errors is the data value. So you just press your data value under the X column as per usual. Okay, so just press 6 equal sign, 9 equal sign to go to the next line. Okay, then 15 equal, 26 equal, 10 equal, 14 equal, 21 equal, and 3 equal. Okay, so there are actually 8 data sets over here. So I do the same for the other one. Okay, 6, 9, 15, 26, 10, 14, 21, 3. Okay? In this particular question, we know that the frequency is 1, so no need to go and change the frequency value. So just keep it to the default 1. Okay? Just keep it to the default. Okay? Calculate ready? Alright? Now, sorry, sometimes having to use 2 calculators, I will forget. It's a lot of trial and error on my part also. Sorry, let me try this again. I forgot the Casio 1 already. 26, yeah. Shift 1 for Shift 1. I don't have a shift. I don't have a 1, 4, okay, sorry. Okay, thank you. 6, 9, 15, 26, and 14, 21, 3. Okay. Okay, this one once you reach Casio 1, okay, I zoom out a little. You need to go back to the main screen. You can press AC, okay, press the AC button, right, and then you press Shift. You see that there's a stack sign on top over here, the number 1 button. So press Shift and then number 1. Okay. Go for the number 4 variable or variance. 4, and then you arrive at this page. Okay. Go AC, Shift 1, 4, 2. Okay, 1 and 4. Arrive at this first. Okay, let's arrive at this page first. Okay. Sharp calculator. Hang on. Also, we need to go back to the front page so you can press on your on cancel button. Okay, and then let's change button on C alpha 8. Oh, okay. So once you arrive at this page for the sharp calculator, right? Press on alpha. Okay, number 8. Okay, and then you arrive at this page. Again, press on variable, number 2. And then you also arrive at a similar page. Okay? So we now arrive at this. Now you need to recognize your symbols. Okay? In your calculator. N refers to total frequency, which we rarely use. X bar represents your mean. So we call this X bar. It's a symbol to represent mean. Okay. Number 3 in this case and number 3 in this calculator, okay, is this symbol. Okay, we call it a sigma X, but that represents your standard deviation. Okay. We are not going to be using the one that says SX. Okay? In fact, I also don't know what is that. Alright? So you just need to know these 3. Okay? Yes. Can teach you how to get this page again. Okay? For the sharp one. Okay? So go to the main page, press the AC button. Alright? Then you press Shift, number 1 button, because there is a stat on top. Okay, stat for statistics. Press number 1, then go into number 4 variance. Okay? Shift number 1. Yeah. Your calculator doesn't show this. Oh, I remember yours already. What's this? Okay, so you see I key in the data already. You press the option button. Okay, and number 3, 1 variable calculation, and it shows you like that. Okay, so you need to recognize that the sigma x is an Okay? Yeah, finish. Clear the memory. Memory empty. So second function number. Okay. Once we arrive at this, then the standard deviation, okay, is what we want to find in this question. Right? By right, if I press option number 3 in both calculators, they should give me the same numbers. Okay, so press equal sign. Yes, we get the same number. Okay. Alright. Any questions? Are we good? Okay. I'm really spending the time and effort to teach you how to use your calculator. Okay. Otherwise, I could just tell you go and read your own sheet of paper when you buy your calculator. Okay, and figure it out. Alright? Okay, you should be able to get these values. You don't get? 7.1763 are correct. Okay, I try your calculator. So in answering your practice now 7, part I, okay, when you find your standard deviation, how to present your answer, we will see from our calculator 7.1763, leave your final answer to 3 significant figures, okay, unless specified otherwise by your calculator. Okay, just directly give the calculator value will do, no working required. Okay? Okay? I want you to give this a try. Okay, in pressing your calculator, go and practice. Okay, do your practice now 8B. Okay, practice now 9. Practice now 9 has a different frequency. Okay, just do these 2 questions first. Okay, so that I can help them. I'll write the answers on the whiteboard. Okay, the values? Yes? Okay. I think it's enough for today. Okay. I find it enough for us to learn the calculator already. Yeah? Okay. On Friday, then we go into the other questions, okay, in terms of like how to use standard deviation values, how to use speed and all that. Okay, similar to how we talk about median and interquartile range. Okay, so today just make sure you know how to press your calculator. Friday we continue. Tomorrow for home-based learning, do your homework. That will be good enough. Okay. Anybody else still having problems with calculator though? Okay, I sincerely hope that Jovia is able to follow while he watches the video video at home. Then, a million code do you manage to get? You can figure out your Canon calculator. It's great.